Welcome back, mathematicians. Well, if you have watched part 1 of classifying triangles, you would have learned all the vocabularies of sides and angles. Today, we're going to take it a step further, and this is part 2. We will be naming triangles, and again, this is still a 5th grade math geometry unit. So now that we've got those vocabularies for sides and angles down, we can start to classify these triangles or grouping them. I'm going to look at the sides first. So when we look at the sides, we're looking at the measure or the length of each of the sides. As you notice in my first triangle right here, I have these sides right here, and they also gave me these measures, and I'm sorry I can't draw them exactly, but I just wanted to show you where they are at. And because of that, notice one of the sides is 2 inches, the other is 3 inches, and the other is 4 inches. None of them are the same. Now I'm going to look at my second triangle. My second triangle has 2 sides that are the same length. And now we look at our third triangle. Notice on all of the sides the exact number of ticks on each of those lines. That tells us that these 3 sides right here are exact same lengths. We're going to compare everything to 90 degrees. So when we have a 90-degree angle right here, that 90-degree angle is a right angle. So this tells me that this is a right triangle. Notice in every triangle there are some acute angles. So even though there are 2 acute angles over here, but because there's that one right angle, this whole entire triangle has become a right triangle. We're going to move on to the next type of triangle. And as you can see, this angle right here is less than 90. And as we notice, all of these angles are less than 90. So they're all acute. Therefore, we can call this an acute triangle. And similarly, I can also do the same for my obtuse triangle, because there is one angle that is more than 90 degrees angle. This whole triangle right now has just become an obtuse triangle. So what this means is that a triangle may have more than one name. And that is not an uncommon thing. We also have nicknames as people, so it makes absolute sense if some of our polygons or shapes also have nicknames. Alright, so let's look at this first triangle right here. As you can notice, each of these angles are less than 90, so that's why they're all acute, okay? And we also notice by their sides that each of their side lengths are different, none of them that are congruent. And so they are called a scalene. Full name would be acute scalene triangle. So let's move down right here, and we have this triangle. Remember, we talked about looking for what's unique. Every triangle has acute angles. But what's unique about this one is that it's got a right angle. It belongs to the right triangle group. Now we're going to look at the sides, and each of the sides are a different length. So that's what makes it scalene. So its full name would be a right scalene triangle. And we're going to go down to the last one right here. And again, it's the same concept. I will let you look at it. Look for what's unique about it. This angle is more than 90 degrees. So a 90 degree would look like this. Okay, and this angle is more than 90 degrees. So we call this obtuse. But notice its side lengths, none of them are the same. So it's also scalene. So this full name for this triangle is called an obtuse scalene triangle. And we do the same to isosceles. Do you notice the 2 sides that are the same? Okay, right here. We have two sides that are the same. That's why it's called an isosceles. But when we look at the angles, all of these angles are less than 90. So that's why it's called an acute isosceles triangle as the full name. Okay, and I'm gonna let you right here to pause this video at this time so that you can look and teach yourself why this one is called a right isosceles and why this one is called obtuse isosceles. And I also wanted you to look at why this one is called equilateral. The one really unique thing about equilateral though is that it cannot have a right equilateral triangle, nor can it have an obtuse equilateral triangle. If you want to test this out, I like to use popsicle sticks. If you have popsicle sticks at home, you can try to put these popsicle sticks together at a right triangle to see if it works. It actually will not be possible, but there are different ways that you can test it out.